We are going to start with two-dimensional motion in polar coordinates. Two-dimensional motion in polar coordinates. Polar coordinates. Why you need polar coordinates? Basically, coordinates, they will be very useful, particularly in two type of questions here. One related to central force problem. Central force problem. Second, related to circular motion. Circular motion. ठीक है? So particularly in these two cases, when we are going to discuss central force problem, as well as when we will discuss the circular motion, these polar coordinates you are going to find out they will be very useful here. So that's why this time I am going to start with polar coordinates. So two-dimensional motion with polar coordinates. Now, if you are talking about two dimensions, then in general, we assume that these two dimensions as x-axis and y-axis. So this is x-axis and this is y-axis. If you are having a particle here or point here P, suppose it is represented by P, then its coordinate will be x, y. ठीक है? When you are studying some problem in two dimensions will be x-axis and this will be y-axis. Here it will be origin. And any particle or any point in this two-dimensional plane, it will be represented by x, y. So first thing is how to write its position coordinate. So first is how to write its position coordinate or position vector. So position vector, it will be represented by the r vector here like this. What will be this r vector? First, we are going to move in this direction by x distance. So here, in this direction, we are going to move how much distance? X distance. And how you are going to represent this direction, this x-axis, how you are going to represent this direction? By the unit vector I cap. So if you want to reach at this point, first you have to move in the x direction, in the I cap direction by a distance x. So this will be x I cap. Then from this point, suppose this point is A, then from A, you have to move in the upward direction parallel to the y-axis by a distance y. And what is the unit vector in the y direction? That will be j cap. So this will be yj cap. So in Cartesian coordinate system, in two-dimensional system, xy planar system, basically position vector that is represented by xi cap plus yj cap. So here, this I cap and j cap, they are the unit vectors in the x direction and in the y direction. So in vector systems, basically directions, they are represented by the unit vectors. So x direction is represented by I cap, y direction is represented by j cap. So they are the unit vectors in the x and y direction. So mode of I cap is equal to mode of j cap, and this will be 1. Their magnitude will be 1. So magnitude of I vector and j vector, that is 1. That's why they are unit vector. So this is what? This is position vector in xy planar system. So what is this? This is position vector. Position vector. So any point or particle in this two-dimensional plane, it is represented by the position vector r vector. Now what will be the velocity? Next will be, when you are studying kinematics, basically what will be v vector? That will be, you are going to represent it by dr by dt. The rate of change of position vector, that is called as velocity. This is actually instantaneous velocity. So velocity will be dr by dt. So here, look here, x-axis and y-axis. This x-axis is fixed. This y-axis is fixed. So I vector and j vector, they are the constant vectors. So remember this, in the xy coordinate system, this I cap vector and j cap vector, they are the fixed vectors here, constant vectors. So if you take the differentiation of this d I cap by dt or d j cap by dt, that will be 0. So what I am saying here, that this j cap vector is a constant. ठीक है, j cap vector and I cap vector are constant vectors. Are constant vectors. So if they are constant vectors, then automatically d I cap by dt as well as d j cap by dt, that will be equal to 0. So here they are the fixed vector. Direction is not going to change. Magnitude is not going to change. So that's why d I cap by dt as well as dj cap by dt, that will be 0. So if you differentiate this d r vector by dt, then this will be simply dx by dt, and this will be I cap. Second term should be plus x di cap by dt, but that is 0 here. So that's why you are just writing dx by dt I cap plus dy by dt, and this will be j cap. You can write this v vector as x dot I cap plus y dot j cap, or you can write it as vx I cap plus vy j cap. So in xy coordinate system, in this two-dimensional system represented by xy system, velocity vector is written like this. Now if you differentiate this again with respect to time, you are going to get the acceleration. So acceleration will be dv by dt, dv by dt. So differentiate again. So this will be x double dot. This will be x double dot I cap plus y double dot j cap, or you can write ax I cap plus ay j cap. So you are well aware about this system. This planar system represented by x and y axes. So this is a well-known system to you. One more question. I just want to ask you why you are saying that this is the direction of I cap. Why you are choosing that this is the I cap direction or this is the j cap direction? Why you are not choosing that I cap is in this direction? Why? You are not saying that this j cap is in this direction. Because I cap is the direction of x-axis. Its direction will be the direction in which x coordinate is going to increase. So what will be the direction of I cap or unit vector? The direction in which x coordinate is going to increase. That will be the direction of x-axis represented by I cap. The direction in which y coordinate is increasing, that will be the direction of the y-axis, and it will be represented by the unit vector j cap. So basically direction of I cap and j cap, they are chosen in such a way that these are the directions in which x coordinate and y coordinate, they are increasing. So this is the way to represent or to choose the direction of unit vectors. So this is two-dimensional XY system. Okay? Two-dimensional system where one axis is represented by the fixed x-axis and another direction is represented by the fixed y-axis. So this is one system, you are well aware of about it. Now, suppose this is our XY system. This is x comma y system, xy coordinate system. This is origin, and I'm representing this point or particle P. This is some point P. I'm writing here. This is point P, and it is represented by x comma y. X comma y. Okay. Now, what will the length of this? This is a position vector here. ठीक है ना? This is a position vector, and position vector is written as r vector. So what will the magnitude of this position vector? Magnitude of the position vector will be this, and we are going to represent it by simple r. So if you are writing simple r, it means this is the magnitude of the position vector. So this is r. And if I consider that the angle this position vector is making with the x-axis, that is theta. That is theta. Okay? That is theta. So here, this is the position vector OP. Okay? This is the position vector of this point P. And length of the position vector is r. Okay? And I am assuming that this position vector is making an angle theta with the x-axis. Then what can be the coordinate of this system? So if this is r, then this length from here to here, this will be r cos theta. And what we are saying that this is x. We are saying this length is x because its coordinates are x and y. So what will be x? X will be r cos theta. R cos theta. Now, next, if you resolve this r vector in this direction, in the y direction, then this length, this will be r sine theta. And we call this length as y. So x and y coordinate, they can also be written as r cos theta and r sine theta. So now what will be the position vector? Position vector now you can write as xi cap plus yj cap. So this will be r cos theta, theta I cap plus r sine theta, theta j cap. J cap. So here, what you have done here, you have transformed this x and y, you have written this x and y coordinate in terms of two new variables. One is r, another is theta. So here you have replaced these two variables x and y by two new variables r and theta. So what you are doing here, you are doing this transformation. From xy coordinate system, you want to transfer to the r and theta system. This r theta coordinate system, this is called as polar system, polar coordinate system. So now, if you are having x and y, what will be the value of r here? So from here, I can also write if x and y is known to me, then make the square of these two equations and add. So this will be r square cos square theta plus r square sin square theta. So this will be r square. And here it will be x square plus y square. So what will be r here? R will be equal to square root of x square plus y square. You can also find out theta. If you divide second equation by the first one, r will cancel out and you are going to have tan theta equal to y by x. So you can write theta equal to tan inverse y by x. So here, these two equations, they can be known as the transformation equation. Here, from x and y coordinates, you are moving to two new variable, two new variables r and theta. Their values r and theta, you can calculate them if you are aware about this x and y. If you are aware about x and y values, then automatically you are going to find out this r and theta. Now, so these are two new variables. Now, corresponding to r and corresponding to theta, I want to create new directions. Okay, here my earlier system was in terms of x and y. So along the x-axis, I cap was the vector. Along the y-axis, y cap was the along the x-axis, I cap was the unit vector. Along the y-axis, j cap is the unit vector. But now I'm doing the transformation of variables here. From x and y, I'm transferring to r and theta. So now I want to define two new directions, two new mutually orthogonal directions. Okay? So now I want to move to a new orthogonal system of axes which are going to represent these variables r and theta. So what will be the direction of this r? Okay? Corresponding to r, what will be the direction? So first I have to find out the direction corresponding to this variable r. So what will be the direction corresponding to variable r? Variable r. That direction will be in which this r variable is increasing. What will the direction corresponding to r variable? That will be the direction in which r is increasing. So basically here r is increasing. So direction will be, it will be the direction in which it will be the direction in which variable r is increasing. In which variable r is increasing. Now, if you look at this diagram, in which direction this r is increasing? Now you are going to tell me the direction in which this r is increasing. This r is increasing in this direction. Just so this is the direction in which r is increasing. So this is the r cap direction. This is a unit vector corresponding to r variable here. So basically value of r is increasing. ठीक है ना? Value of r is increasing in this direction. So this is a unit vector in this direction. It is represented by r cap. So this direction, it will be represented by r cap. And what you call it as? You call it as radial direction. ठीक है ना? You call it as radial direction. Direction or radially outward direction. ठीक है ना? Radial direction with respect to the origin. So what will be the r cap direction? So you connect the origin with that particular point and extend this line in the forward direction. So r is going to increase in this direction. So this will be the direction of the radial variable. ठीक है ना? This is the direction in which this r is increasing. So this is called as r cap direction or radial direction. Now, but this point can be anywhere. Try to understand. This point may be here, this point may be here, this point may be here. Suppose this point P is here. Okay. Suppose this point P is here. Then what will be the radial direction? So this radial direction will be here. So here it will be the radial direction. Radial direction. So try to understand if you are attaching this position vector with a particle that is moving, then direction of this r cap vector is continuously going to change. So this time now dr cap by dt, that is not going to be 0. So r cap is not a fixed vector. As the particle is going to move, its position vector is going to change. And as its position vector is going to change, this r cap direction is going to change. So we are creating a new axis system, new orthogonal axis system, okay, in which direction of r cap is not fixed. This is not a constant vector. dr cap by dt, that is not going to be 0. So remember this. So that's why it is different from this xy coordinate system. In xy coordinate system, I vector and j cap vector, I cap vector, j cap vector, they were the fixed vectors, fixed unit vectors.
Sir,
But
if
yes.
sir, if there is a circle, so we can say that there is also the r cap is increasing or decreasing. Sir, in the
No,
circle,
in
the
radial direction, R will be constant. I will come to your question. Okay, I will explain you the circular motion here today
okay,
itself.
okay,
But in case of circular motion is defined in such a way that a particle is moving in a two-dimensional plane in such a way that its distance from a fixed point, you call it a center, is always constant. Throughout
yes,
its motion, that distance will remain constant. So small r, that will be capital R, and that will be constant. So r dot will be 0, but radial direction will be there. ठीक है, if you are having a circular motion, radial direction is always there. If you look at the centripetal force, what is the direction of centripetal force? That is minus r cap direction. So for the circular motion, there is always required a source of centripetal force. And that source of centripetal force should always act in the minus r cap direction. ठीक है, inward radially. It is radially inward direction, minus r cap direction. So direction is there, but variable r, that is a constant. ठीक है? So
okay,
direction r cap will always be there. So it
thank
is
you, sir.
like this. Now, if you look at this r cap vector, basically it doesn't have any meaning if you are not defining, because this r cap may be here, r cap may be here, r cap may be here. So this r cap, it is not going to have any meaning unless and until you are not defining this theta. ये जो theta है ना, अगर आप इस theta को define नहीं कर रहे, then automatically this doesn't have any meaning. ठीक है? So first you have to define this theta. So basically the meaning of this r cap direction is only when you are defining this theta. So chorus, another variable is theta. So if I'm telling you that theta is 30 degree, then you are defining a particular r cap direction. That is okay. But if I'm not telling you theta, then this r cap can be anywhere. You cannot tell me, okay, this is the direction r cap particularly. So you need this, a direction corresponding to theta also. This is another variable. So direction of theta will also be in such a way that in that particular direction, theta should increase. Theta should increase. So what will the direction in which theta is increasing? That direction is perpendicular to r cap here in this direction. So try to understand, this is the position vector. So if theta is increasing, it will move like this. Theta is increasing in this direction, in anti-clockwise direction. Theta is increasing in anti-clockwise direction. So this is theta in anti-clockwise direction. So it is going to increase like this. So it will be perpendicular to r cap always. So this will be theta cap direction. This is theta cap direction because it is perpendicular to r cap, and in this direction theta is always increasing. It's not in the reverse direction, because in this direction theta is going to decrease. So unit vectors are defined in such a way that they are representing the direction in which variable is increasing. So theta is increasing in this direction, it is going to rotate in anti-clockwise. So it will always be perpendicular to the position vector or this r cap. So this is r cap, this is theta cap. This is r cap and this will be theta cap. So now you have created a new orthogonal system made up of r cap and theta cap. This coordinate system made by r cap theta cap, that is called as polar coordinates. Okay? That is called as polar coordinate system. So basically the system that works in terms of r and theta, that is called as polar coordinate system. Polar coordinate system. Sorry.
सर आई हैव क्वेश्चन जैसा आपने
Okay,
बताया
just,
कि
and this is
विदाउट
orthogonal. Just one second, beta. It is a orthogonal coordinate system. It is also orthogonal coordinate system. Yes, beta, please.
R is depend on
R
tau
is
theta, we
dependent.
can't define R.
R cap.
है ना, तो R cap
नहीं,
से मतलब
R can
theta
be
पे
R. You can tell me the value of. You can tell me the value of R, magnitude of position vector, but it doesn't
okay.
have any meaning if you don't have theta. ठीक है? Can you draw R cap direction without knowing theta?
No sir.
No. So that's why I'm
Sir,
saying. So they are dependent on, means they are, R is having its meaning only if theta is there. Yes, beta.
Sir, orthogonal coordinate system means the dot product of these two coordinates is 0? Or
Yes,
what?
beta. ठीक है. Question is orthogonal coordinate system. Orthogonal coordinate system.
Sir, please, previous slide.
Just 1 minute, beta. I will show you. So basically, if you are having I cap dot j cap, what you are having, you are 0. You are getting 0. ठीक है? Cos 90 is 0. Similarly here, if you are having R cap dot theta cap, then angle between them is 90 degree, so it will be 0. Why you are choosing orthogonal coordinate system? Because due to this property, due to this orthogonality, you can resolve the motion in a plane into two independent motions. Try to understand. You can, due to this orthogonality, why you are writing that R vector is x I cap plus y j cap. Try to understand. You are writing V equal to Vx I cap plus Vy j cap. You are writing A vector is equal to Ax I cap plus Ay j cap. So if a particle is moving in a plane, try to understand, like most of the time I give this example because you are all aware about it. This is y, this is x. So if a particle is moving in a plane, for example, projectile motion, you can split this motion, you can study this motion in two independent motion, one in x direction, another is in y direction. Why you can study this independent x directional motion and independently y directional motion? Because this I cap and j cap, they are orthogonal to each other. If they are not orthogonal, then you cannot do this. So here you can even study this motion. This is a planar motion also. You can consider this motion in terms of polar coordinates also. Suppose this is the particular position of the particle, then this will be the r direction. This will be the r cap direction at any time. And this will be theta. And this will be theta cap direction. So that's the advantage. So you can study this problem as two problem, as the superposition of two problem. One particle is moving in x direction, another particle is moving in the y direction. I can study this motion as the superposition of these two motion. One is this. In this direction, this particle is moving with u cos theta, with the constant velocity u cos theta. This is x directional motion, studied independently. Second, in the y direction, it is like this. And here, this is u sine theta in the y direction. So why you are able to split it into two different motion, two independent motion, one in the x direction, one in the y direction? That is due to this orthogonality. Orthogonality gives us this advantage. So that's why in general, we choose orthogonal axis system. Okay. Even in quantum mechanics, when you will study quantum mechanics, you have to choose a basis. Okay, it's not necessary that basis is always orthogonal, but in quantum mechanics, there is a you can say there is an advantage if you choose the basis vectors orthogonal to each other. So orthogonal basis, if you are choosing, that is always That is always advantageous. Why? Because you can consider all these motions, ठीक है ना, independent of each other. That's why you always try to choose the orthogonal axis system. Yes, beta,
Sir,
please.
in the classical mechanics, if I consider the I cap dot I cap is equals to 1, this means that the normalization condition.
Yes. Normalization condition. Yes. ठीक है ना? Now, come back to, yes, beta.
Why is that R cap is not a constant?
R cap is not a constant because you are choosing what is this, what is this P particle? This is a particle. If particle is changing its position, if particle is moving, in kinematics, particle is going to move. So automatically it's a position vector that is going to change. So ये जो position vector है ना, that is going continuously, it is going to change. And when it will change, automatically this position, this R cap direction, that is also going to change. So that's why this R cap is not a constant vector. ठीक है, जो इसका direction है, direction of R cap is not constant. ठीक है, its magnitude is unity magnitude. Magnitude is 1. That's okay. But its direction, it will continuously change if particle is going to change its position. So that's why this is not a constant vector. Is it clear, beta? What I'm saying?
Okay, sir.
The
Okay, beta. Yes,
Sir,
beta,
we
please.
said these point are this is the orthogonal coordinate system because the theta is always perpendicular to the
Theta
radial.
cap. Theta
Yeah,
cap is
R cap.
always perpendicular to R cap.
That's why we call it orthogonal coordinate
Yes,
system.
beta. That's why this is called as orthogonal coordinate system.
Okay.
Next. Now suppose this is x-axis, this is y-axis, and this is origin. Here, if a particle is represented, position of the particle is represented by this position vector R vector. Its magnitude is this R. Now, ठीक है? Now, this is my R cap direction. Try to understand this is R cap direction. And I know magnitude of R cap is 1. Now, if I draw an axis parallel to X here, if I draw an axis like this is parallel to X. And another axis that is parallel to Y, like this. This angle, it will be theta. So automatically this will be theta. So what will be the component of R cap parallel to x-axis? Component of R cap parallel to x-axis, what it will be? This will be cos theta only. Because component will be magnitude of R cos theta, but magnitude of R is 1. So its length is 1. So this will be 1 cos theta. And in this direction, it will be 1 sin theta. So component of R cap in the direction of, so here component of this R cap, ये जो R cap vector है, component of this here in the x direction, this is cos theta. And its component in the y direction is sin theta or 1 sin theta or 1 cos theta. You can write like this. So can you now represent this R cap? So R cap vector, this R cap vector can now can be expressed as x component is cos theta. So this will be cos theta I cap plus this will be sin theta j cap. This will be. So in this way, you can represent this R cap vector in terms of cos theta and sin theta. ठीक है? In terms of cos theta, sin theta in the direction of I cap, j cap. So this is the correlation between R cap and I cap, j cap in this way. Similarly, you can represent this theta cap also. So if you are having, you want to represent theta cap, then it will be like this. This is x, this will be y, origin, and suppose this is the position. This is position vector here. So this will be R cap. r cap. Perpendicular to r cap, this will be theta cap. This will be theta cap. ठीक है? Theta cap. Now, this direction, this is theta. So this angle will be theta. So I draw this x-axis. Another will be this. This is parallel to y-axis. So now this theta, this is 90 minus theta. So automatically this will be theta. So what it will be? This will be theta. Theta. Now resolve this theta. ये जो theta है, theta cap. Resolve this parallel to x-axis and parallel to y-axis. Remember this, magnitude of theta cap is again 1. So if I resolve this in this direction, this direction, and I can resolve this in this direction. So in this direction, it will be, the magnitude is 1, length is 1, for this vector length is 1. So this will be 1 cos theta. So in this direction, it will be cos theta. And in this direction, this will be minus sign will be there, but because arrow is already there, so this will be sin theta. Sin theta. So how can you represent this theta cap? Theta cap, it can be represented. It is in minus x cap direction, length is sin theta. So this will be sin theta with minus sin theta I cap. Minus is representing that this component is in minus I cap direction. Plus cos theta, and this will be j cap. This will be cos theta j cap. ठीक है ना? So these are transformations. ठीक है ना? These are transformation of one type of unit vector system to another unit vector system. So r cap and theta cap, they can be written in terms of I cap and j cap. Or if you combine these two equations, this transformation can also be written in the form of matrix. It will be like this, and this will be cos theta, sin theta, and this will be minus sin theta, cos theta, and this will be I cap j cap. So this transformation, it is represented by the rotational transformation. ठीक है ना? तो ये क्या है? Rotational matrix है. What is this? If you remember this, if you can consider this, recall it, this is rotational matrix. So basically this is the transformation equation from I cap j cap axis system. You can transform to r cap theta cap system. ठीक है ना? This is transformational matrix. ठीक है? This is transformational matrix, rotational matrix actually this is. ठीक है? This is actually the rotational matrix. So with the help of this matrix equation, you can transform from xy coordinate system to the polar coordinate system. You can move. ठीक है? Reverse of this is also possible, but before that, now remember this I cap and j cap, they are constant vectors. They are constant vectors. But this r cap and theta cap, they are variables. ठीक है? They are variables. So this r cap can be in this direction, r cap can be in this direction. Correspondingly, theta cap is also going to change. Theta cap भी correspondingly change होगा. Next is, so r cap is this. So r cap is cos theta I cap plus sin theta j cap. Theta cap is equal to minus sin theta I cap plus cos theta j cap. It is like this. Now what will be dr cap by dt? What will be dr cap by dt? dt, we are saying they are not constant vectors. So we should be able to find out dr cap by dt. What it will be? So here it is. This will be cos theta का कितना होगा? That will be minus कितना होगा? साइन थीटा एंड क्या होगा बेटा बताओ, एंड थीटा डॉट डी थीटा बाई डी टी।
dt.
तो कॉस थीटा का कितना होगा, माइनस साइन थीटा एंड डी थीटा बाई डी टी। सो दिस विल बी डी थीटा बाई डी टी, आई कैन राइट इट एज थीटा डॉट, and this I cap will be as it is, plus cos theta. You are differentiating this with respect to time. So you are differentiating this cos theta. Theta is not a constant. If particle is moving, theta is going to change. So differentiation of cos theta will be minus sin theta and then d theta by dt. So theta dot will also be there. I cap plus cos theta as it is, and this will be d I cap by dt. And this is 0. That's why in most of the books they are not writing it. Plus sine theta, differentiation of sine theta, it will be cos theta, and this will be theta dot, and this will be j cap plus sine theta dj cap by dt. But they are constant vectors, that's why we are taking them 0. Now from here and here, take this theta dot common. So if you take this theta dot common, then what you are going to be left with, minus sine theta I cap plus cos theta j cap. What is in here in the bracket? This in the bracket, this is the definition of theta cap. Whatever bracket is here, that is theta cap. If you look at this, is minus sine theta I cap plus cos theta j cap. So dr by dt, dr cap by dt, this will be theta dot, and this will be theta cap. So this will be dr cap by dt. This will be like this. Now, second, this is first, you can say this is A. B, differentiate this theta cap with respect to time. So d theta cap by dt. This will be sine theta. Differentiation of this will be cos theta. So minus cos theta dot, and this will be I cap. Here this is cos theta, so this will be minus sine theta dot j cap. Two other terms I have directly written as 0. So here if you take minus common, then this will be minus theta dot common, then this will be cos theta I cap plus sine theta j cap in the bracket. You will be left with this bracket. What is this bracket? This is r cap. This is r cap. So you can write it as minus theta dot r cap. So this d theta dot by dt, this will be minus theta dot, and this will be r cap. This is theta cap, beta, sorry. This is theta cap. It will be d theta cap by dt equal to minus theta dot r cap. Okay, now this is. Now, is it okay? So basically r cap direction and theta cap direction, they are variable. They are variable. So here, if you look at this r cap direction, okay, na, it is somehow, it is depending upon theta cap. If you are taking its time variation, then time derivative, then it will be in terms of theta cap. And if you are taking the time derivative of theta cap, so it will be r cap. It will appear in terms of r cap. Now, next, what will be the position vector? Yes, beta, please.
Sir, why we write no, theta dot? I mean,
D
what is
theta
meaning of
dot?
dot?
Theta dot is d theta by dt. Okay? If you are differentiating cos theta, suppose, with respect to d theta, d by d theta. You are differentiating like this. What it will be? This will be minus sine theta. And then there will be d theta by d theta. That will be 1. But if you are differentiating this cos theta with respect to time, d by dt, then it will be minus sine theta. And theta is also changing. So it will be d theta by dt. And it will be minus sine theta. And you write it as theta dot. Theta dot means d theta by dt. Is it okay now?
Yes, sir. Thank you.
Sir,
Yes, beta, please.
this equation d r cap over dt is equals to theta dot theta cap. So
Yes.
the meaning of this equation is that if the r cap is increasing with time, so
Yes.
the theta dot means angle is also increasing with time in the direction of theta cap.
Yes. It is happening.
Okay, okay.
ठीक है ना? So
Yes, sir.
that's like this. So next is position vector. Now we are able to write the position vector. Position vector. So next is position vector. So how you are going to write the position vector? Position vector is r vector. How you are defining position vector? R vector. This is x I cap plus y j cap. J cap. Now x is r cos theta I cap plus r sin theta j cap. So take this r common. R is the magnitude of the position vector. So take it r common. This will be cos theta I cap plus sin theta j cap. And if you look at the definition of r cap, ठीक है ना, this bracket term, it is actually equal to r cap. So this will be r cap. So position vector in polar coordinates, it is written like this. R vector is what? R vector, direction of the R vector is represented by this R cap, and magnitude of this R vector is represented by R. So vector is having two aspects. One is its direction, another is its magnitude. So this R cap, it is representing the direction. And this is small r, it is representing the magnitude of this vector. So position vector can be written like this. But here in position vector, theta directly is not appearing, but if you take the time derivative, then automatically theta will come into the picture. So that is hidden. Here, theta is not appearing, but theta is hidden there. Okay, without theta, there is no meaning of r cap. Remember this. So in many books, to understand this, to explain this aspect, many times they are going to write like this, that theta is there inbuilt in r cap. Theta is inherent part of this r cap. So you can also write it like this. So this is the position vector. This is the position vector beta. Second is velocity. Second is velocity. Just wait 1 second beta. Sorry. Please.
Okay, sir. Thank you, sir.
Okay. Next is velocity. So r vector is how you are writing r vector in polar coordinates. This will be r magnitude and this will be r cap. Now you know velocity, instantaneous velocity, this will be dr by dr vector by dt. This will be d by dt. And r vector is r cap. R cap. So v vector it will be dr by dt. And this will be r cap. Plus r will be as it is, and this will be d r cap by dt. So dr cap by dr by dt, you can write it as r dot. dr by dt means how r is changing with respect to time. So this will be r cap plus r. And what is dr cap by dt? I have just calculated that will be theta dot theta cap. Theta cap. So this will be the velocity vector in polar coordinates. In polar coordinates, this will be the velocity vector. So velocity vector will be equal to VR, radial component of the velocity, in the r cap direction plus, ठीक है, r theta dot. This is called as v theta, tangential direction. ठीक है ना, tangential direction. So this will be theta cap. So this is radial velocity. This is tangential velocity. What you call, I will write what is VR here, where VR is r dot. R dot, or you call it as dr by dt. This is called as radial velocity. Radial velocity. This is called as radial velocity. And what is v theta? V theta. V theta is r theta dot. R theta dot. This is
Dot is
angular velocity. Theta dot is angular velocity. You also write it as omega. So what is theta dot? You can also write theta dot as omega, and it can be d theta by dt. You call it as angular velocity. This is angular velocity, omega. Angular velocity. This is angular velocity. So it will be, so v theta equal to this and r omega will be this. Is it clear? So this is radial velocity and this is tangential velocity. The unit for both radial velocity, it will be meter per second. So don't confuse. And unit of this will be meter per second. But unit of this, it will be radian per second. Radian per second. So now try to understand, if you are having a particle like this, it is moving. So I'm having some particle. This particle is there. This is O, this is x-axis, this is y-axis, and here I'm having a particle. And this particle is having some velocity. It is having this velocity v. This particle is moving in this direction. This is v. This is the particle. So component of this velocity here in the direction of r cap, this will be vr. And this direction is r cap. And component of this here in this direction, this will be vt. And this is theta cap direction. So this is radial velocity. This is tangential velocity. This is radial velocity and tangential velocity. If you look at circular motion.
Sir, 1 minute.
Previous lecture.
Okay, beta.
Okay.
Now, if you look at circular velocity, sorry, circular motion. So I am writing here circular motion. In circular motion, R, it will always be equal to capital R. So automatically R dot will be equal to 0. If R dot is 0, then automatically VR, radial component VR, that is equal to R dot, that will be 0. Vt will be there, tangential velocity will be there, and this will be R theta dot, or you can say that will be R omega. So basically in circular motion, only one type of velocity exists, that is tangential velocity. So if the particle is here, it is moving on this path, on this circular path, then there will be only one type of velocity. This will be tangential velocity Vt. And Vt will be R omega. Remember this. Vt will be R omega. It may be this Vt, it may be constant in magnitude. In that case, if Vt is constant, you call it as uniform circular motion. If Vt is changing, then you call it non-uniform circular motion. So here in circular motion, as there was a question, so this is the tangential velocity. In radial direction, it is not moving. That's why radial velocity is 0. But if you look at a particle undergoing motion on an elliptical path, suppose this is the source under which this particle is moving. This particle is moving like this. This is particle of mass m. So its radial position will be this. Its position vector, you can say, it is this. So this will be the radial direction. This will be r cap direction. And perpendicular to this will be theta cap. Remember this. Theta cap. Now look at the velocity. What will happen to velocity? Velocity is always tangent to this path, elliptical path. So basically this will be the velocity. So one of the component of this V, that is VR, it will be, ye kaun sa component hoga, that will be VR, that is acting towards the source. This is the source under which this particle is moving. And this component VT, it will be here. So here, both the components are there. Both the velocity components are there. Radial velocity component is there. Tangential velocity component is there. So tangential is not like this always in this direction. Tangential component is in the direction of theta cap. So first draw the r cap, then this is theta cap. So this velocity can be written as in the components of VR and VT. If your object is here, okay, no problem, then this will be the position vector. This will be the position. This is r cap.
Sir, what is S?
What is?
S.
S is the source. S is the source under the influence of which this particle is tracing this ellipse. ठीक है ना? Particle is undergoing a motion on the elliptical path. So there should be some source. Source is here. Now, if this is the particle, then what will the radial direction? This is radial direction, and this will be theta cap. Theta cap direction. Okay? Because angle you are going to measure like this. In anti-clockwise direction, it will be like this. So this is theta cap. If velocity is there, velocity, this particle is moving like this. So velocity will be here in tangential direction. So a component of it will be here, VR. Now VR is in outward direction, radially outward. Here it was radially inward. And this will be VT component. This will be VT. If you look at this,
Sir,
just बताओ.
टेंजेंशियल कंपोनेंट इनसाइड एलिप्स हो सकता है?
क्यों नहीं हो सकता? टेंजेंशियल कंपोनेंट मींस किसके टेंजेंशियल मतलब आप सर्कुलर मोशन में जा रहे हो, इन सर्कुलर में वो टेंजेंशियल हो गया, तो आप ये ट्रांसवर्स कंपोनेंट कह सकते हो इफ यू वांट, इफ यू आर हैविंग वर्ड से वो है, देन यू कैन कॉल इट एज ट्रांसवर्स टू आर कैप डायरेक्शन, ठीक है, ट्रांसवर्स टू आर कैप.
Vt is the tangential velocity.
VT. No, tangential, you can say it as transverse direction in theta cap direction. Actually, for when you are studying circular motion. So
And sir,
basically
here
this
is
just listen. Basically this VT is always at the tangential position. So you call it at that position, you call it as tangential velocity. Here you can call it as transverse component of the velocity. But remember this is in theta cap direction. ठीक है, so if you want to say it with another name because it is not looking like tangential, ठीक है, so this will be transverse component in theta cap direction, ठीक है.
If
Yes beta.
the motion is circular, then theta cap will be other side. Right?
Yes, ठीक है, this will be V. Actually in circular case, if particle is undergoing this, then this VT, it is always tangential, so that's why we call it as tangential velocity here, but you can call it as transverse velocity, ठीक है.
here is radial
Sir, why
velocity.
can't we not take the theta in clockwise direction?
This is a when this system was developed, so convention is this, we are considering anti-clockwise direction, ठीक है, this is a convention, ठीक है. So today
And sir,
I'm going to
here,
stop here beta, in the next class I
here
will
is the
continue from
direction of
here.
r cap, no?
Where is r cap? R cap is here, r cap is here, this is the r cap, if here this will be the direction of r cap. So
Okay,
in the
sir.
next class I will continue from here itself.
Sir, can you
Chaliye beta,
please
thank you.
show the second slide once more?
Okay, beta. I can show you all the slides from first to last. This is the first one. Second one. Third one. Fourth. Fifth. Sixth. 7. 8. This is the last one.
Thank you, sir.
Welcome, beta.
Thank you, sir.
Welcome, beta.
Thank you, sir. Thank you, sir.
Good night, sir.